Welcome to another deep dive, this time into the world of weather forecasting. Well, it seems like artificial intelligence is making a real splash.
It's certainly causing a stir.
That's for sure. We've got some listener research on a system called AIFS-CRPS. I hope I'm saying that right.
You got it.
Okay, good. And it sounds like it's already turning heads in meteorology, so I'm excited to break this down with our expert.
Happy to be here.
So, right off the bat, AIFS-CRPS, what is that?
What stands for Artificial Intelligence Forecasting System, Continuous Ranked Probability Score. It's a mouthful, I know.
Yeah, bit of a mouthful, but it's a machine learning model, right?
Right. Developed at the European Center for Medium-Range Weather Forecasts.
Okay, so we're talking cutting-edge stuff here, but what exactly makes this system so special? I mean, we hear about AI and machine learning all the time these days.
Sure. Well, this is different. It represents a big shift from how traditional weather models work. Instead of just giving you a single prediction like the temperature will be 75 degrees tomorrow, AIFS-CRPS generates what are called ensemble forecasts.
Ensemble forecasts. Okay, I'm intrigued.
It considers a range of possible weather scenarios and assigns probabilities to each one. So instead of just one outcome, you get a spectrum of possibilities with their likelihoods attached.
So it's not putting all its eggs in one basket, so to speak?
Exactly. It's like having a range of possible futures instead of just one that might not even be accurate.
I can see how that would be useful, especially for people making decisions based on the forecast.
Right. Think about a farmer trying to decide when to plant their crops, or a city preparing for a potential heat wave. Having that range of possibilities gives them a much better basis for planning and making those critical decisions.
That makes a lot of sense. Now, I know the system is all about probabilities, and we keep hearing this term CRPS. What is the continuous ranked probability score? Why is it so important?
CRPS is basically how we grade these probabilistic forecasts. It tells us how well the predicted probabilities match what actually happens in the real world.
So it's a way to measure how good the AI is at its job?
You could say that. The lower the CRPS score, the better the forecast accuracy. It's all about aligning those predictions with reality.
Okay, so lower scores mean we can have more confidence in what the AI is telling us. Now, the research you said mentioned something called FAIR and almost FAIR CRPS.
Oh, right. Those are modifications to the standard CRPS calculation.
Mhm.
They're there to adjust for certain biases that can come up because we're working with a limited number of ensemble members.
Ensemble members being those different possible scenarios we talked about.
Exactly. It's all about fine-tuning the calculations to make sure the AI's probabilities are as accurate and representative as possible.
So it's like making sure the AI isn't playing favorites with certain weather outcomes.
That's a good way to put it.
Okay, well, let's get down to brass tacks. What kind of results is this AIFS CRPS system actually producing? Is it living up to all the hype?
It's performing remarkably well, especially for what we call medium-range forecasts. That's looking ahead up to 15 days.
So not just tomorrow's weather, but a good chunk of time into the future.
Exactly. And in many cases, it's actually outperforming the traditional IFS Ensemble, which is the European Center for Medium-Range Weather Forecasts' own physics-based system.
Wait a minute. So we're saying this AI is going toe-to-toe with what's considered the gold standard of weather forecasting. And in some cases, even winning.
That's what the research suggests.
Wow. So what types of forecasts is it particularly good at?
It seems to excel at predicting upper air variables,
Sure.
things like geopotential height and wind speed. These are crucial for understanding large-scale weather patterns. And what's even more exciting is that when they increase the model's resolution for surface variables like temperature and precipitation, its performance gets even better.
Okay, so we're talking about more accurate and detailed forecasts of the things that directly affect our daily lives. That's where it gets really interesting for our listeners, right? I mean, who wouldn't want a more reliable heads up about what kind of weather is coming their way?
You've got that right. And it's not just about knowing whether to grab an umbrella. Better forecasts can have a huge impact on agriculture, disaster preparedness, energy management, transportation. The list goes on.
Potentially saving lives, money, and resources. So let's dig into what makes AIFS-CRPS so effective. What makes it stand out from those earlier machine learning models that we talked about?
One of the things that really impressed me is that AIFS-CRPS doesn't suffer from the smoothing issue that plagued earlier models. Remember how we talked about traditional models losing those crucial details about variability over time?
Right, they sort of average things out and you lose that fine-grained information that can make all the difference.
Exactly. AIFS-CRPS manages to maintain a much more realistic level of variability in its forecasts, even when we're looking further ahead. And this is critical for predicting extreme weather events. things like cyclones and storms. Those often depend on very small-scale details that other models might miss.
So it's like having a high-definition picture of the future of weather as opposed to a blurry one.
You got it. And that level of detail could be a game changer for preparedness and early warning systems.
Absolutely. Now let's talk about something that honestly just blows my mind. We've been focusing on these medium-range forecasts, but what about predicting weather patterns weeks or even months in advance?
Yes, you're talking about subseasonal forecast.
Right. I always thought of that as almost impossible, like trying to predict the unpredictable.
It's definitely a huge challenge. You're bridging the gap between weather and climate predictions, and the dynamics get a lot more complex.
Right. So what's the story here? Is AIFS-CRPS up to the task?
Well, this is where it gets really interesting.
Yeah.
Even in this domain, AIFS-CRPS is showing some real skill.
You're kidding. What's the research saying about its performance in this area?
Well, despite being trained mostly on shorter-range forecasts, AIFS-CRPS is generating some promising results for these subseasonal predictions. In fact, it's even outperforming the traditional IFS model in predicting something called the Madden-Julian oscillation.
Okay, whoa. Hold on. Before we go any further, break that down for me. What is the Madden-Julian oscillation, and why should our listeners care about it?
The MJO is a massive weather pattern that starts in the tropics, but it can have ripple effects all around the globe. It's like a giant pulse of increased rain and wind that slowly travels east across the tropical regions. And predicting its movements accurately weeks in advance could be huge.
Okay, so we're talking potential impacts far beyond just the tropics. Give us some concrete examples. How could this affect people's lives?
Imagine being able to anticipate major shifts in weather patterns weeks ahead of time. This could transform how we prepare for disasters, how we manage resources, even our understanding of long-term climate trends.
Wow, this AI is starting to sound like a crystal ball for weather. But even with all these incredible capabilities, I'm guessing there are still some challenges that the researchers are wrestling with.
Of course, no model is perfect. One thing they point out is that AIFS-CRPS can sometimes be a bit over-dispersive. That means its range of predicted values can be wider than the actual range of errors.
So it's like casting a wider net than necessary.
Exactly. And they think this might be connected to how initial conditions are represented in the model.
Meaning?
Well, it's kind of like if you were trying to predict where a leaf would land after falling from a tree. Even the tiniest differences in wind or the leaf's starting position can lead to totally different outcomes.
So those tiny variations at the beginning can snowball into big differences down the line.
Exactly. But the good news is the researchers are already working on ways to refine this part of AIFS-CRPS to make it even more reliable.
That makes sense. It seems like this constant refinement is all part of the process. Are there other challenges on the horizon?
Well, another area where AIFS-CRPS isn't quite as strong as the traditional IFS is in forecasting conditions in the stratosphere.
So it hasn't quite conquered the upper atmosphere yet.
Not quite,
Hmm.
but they're working on it. They're looking at ways to adjust how the model learns from the data to improve in this area. It's a delicate balancing act, though, capturing all the complexities of the atmosphere while making sure the model stays accurate and reliable.
It sounds like they're really pushing the envelope here. This has been an amazing deep dive so far, and we're just getting started.
There's much more to come.
You got that right. Stay tuned, listeners, because when we come back, we'll be diving even deeper into this fascinating world of AIFS-CRPS and exploring what it all means for the future.
Welcome back. Before we jump into anything new, I want to circle back to something we were discussing earlier. The whole subseasonal forecasting thing. It's pretty mind-blowing, isn't it?
Yeah, predicting weather patterns weeks in advance. It's like something out of a sci-fi movie.
It's definitely pushing the boundaries.
Yeah.
And what's really fascinating is that AIFS-CRPS wasn't even specifically trained for this. It was mainly trained on those shorter range forecasts.
Right, but somehow it's excelling in this super complex domain, almost like a hidden talent.
You could say that. It seems to have a knack for it.
I'm really curious to hear more about how it's doing with the Madden-Julian oscillation. We kind of glossed over that.
The MJO.
Right.
Well, even with the limited amount of data available for this type of forecasting, AIFS-CRPS is consistently outperforming the traditional IFS model across several key metrics.
So it's not just predicting that the MJO will happen. It's actually getting the specifics right, like the timing and strength of it.
That's right. It's accurately predicting the timing and how strong it will be and how it moves across the tropics.
That's incredible. I mean, that kind of information would be invaluable for anyone trying to anticipate those large-scale weather events.
Exactly. And what's even more impressive is how well the model's predictions match the actual uncertainty in these forecasts.
Yeah.
It's striking that balance between confidence and caution, giving us a realistic picture of what might happen weeks in advance.
Right, because with something like the MJO, you don't want to be overly confident, but you also need some level of certainty to make informed decisions.
Exactly. You need to know what you're dealing with. The paper also mentions a case study where they compared AIFS-CRPS and IFS forecasts for a specific MJO event back in 2020. They actually used visualizations to track how this weather pattern moved and intensified over time.
So like a side-by-side comparison.
Exactly. And the results were pretty striking. AIFS-CRPS did a much better job of capturing both the strength and the eastward movement of the MJO compared to the IFS.
So both models were able to predict that something was going to happen, but AIFS-CRPS was much more accurate when it came to the details.
Right, and those details could be crucial for understanding how the MJO will impact regional weather patterns. It's not just a big blob moving across the map.
Yeah.
It's a complex system with real-world consequences.
Absolutely. Now, we've talked about all the amazing things this model can do, but the paper does mention some areas where AIFS-CRPS is facing some challenges, like the over-dispersion issue we talked about.
Right. That's one area where there's still room for improvement, especially for certain variables, like geopotential height. It tends to predict a wider range of outcomes than what actually happens.
So it's erring on the side of caution, casting a wider net than necessary.
You could say that. And the researchers think this might have to do with how the model handles those initial conditions. Those tiny variations in the starting point that can lead to big differences down the line.
Right, it's like that butterfly effect we always hear about.
Exactly. Even something seemingly insignificant at the beginning can have a huge impact on the final outcome. But the good news is they're already working on ways to refine this aspect of AIFS-CRPS to make it even more reliable.
I imagine this constant refinement is a big part of the process with any model. What other challenges are they working on?
Another area where AIFS-CRPS needs some work is in forecasting stratospheric conditions. It's not quite as good as the IFS in that department.
So it hasn't quite mastered the upper atmosphere yet.
Not yet. But they're on it. They're looking at how the model weighs different variables to see if they can tweak things to improve its performance up there. It's all about finding that sweet spot, capturing all the nuances of the atmosphere without sacrificing accuracy.
It sounds like a delicate balance. So much complexity to take into account.
It really is. Now, in addition to tackling these challenges, the paper also outlines some exciting avenues for future research. One thing they're really interested in is incorporating more information about those initial conditions directly into the training process.
So instead of just feeding the model a single snapshot of the atmosphere, they want to give it a richer understanding of all the different ways things could start.
Precisely. That could potentially lead to even more accurate and reliable forecasts, especially those longer range ones. It's all about embracing the inherent uncertainty in weather and teaching the model to navigate that.
So it's not about trying to eliminate uncertainty, but rather to understand it and work with it.
Exactly. Another avenue they're exploring is using higher resolution data throughout the model. They're already seeing really impressive results when they increase the resolution for those surface variables, like temperature and precipitation.
So it's like giving the AI more powerful magnifying glass, so it can see those finer details in the atmosphere.
That's a great way to put it. Higher resolution data can reveal things that would be missed otherwise.
Yeah.
Subtle features, interactions, all that. It's like going from a blurry picture to a crystal clear image of the weather.
Amazing. It's incredible to think how far we've come in weather forecasting, and it seems like we're just scratching the surface of what AI can do.
It's a really exciting time to be in this field. The possibilities are endless.
They really are. Now they're even talking about adding more forecast parameters to the model, beyond just the usual suspects like temperature, pressure, and wind.
Right. They're thinking about things like soil moisture, vegetation cover, even air quality data.
Wow. So it's not just about the atmosphere anymore. It's about understanding how all these different Earth systems interact with each other.
Exactly.
Yeah.
By incorporating more variables, the model can develop a much richer and more complete understanding of how our planet works.
It's like putting together a giant puzzle. But instead of a picture, we're building a model of Earth's climate.
That's a great analogy. The more pieces we have, the clearer the picture becomes, and the better we'll be able to anticipate how all these complex systems will behave.
This has been an incredible journey so far. We've gone from the basics of AI forecasting to those mind-boggling subseasonal predictions. And it seems like the future of weather forecasting is incredibly bright.
I agree. The possibilities are truly vast, and AI is going to play a huge role in shaping that future.
Well, we've covered a lot of ground today, but there's still more to explore. When we come back, we'll be diving into some of the broader implications of this technology and what it might mean for the future of our planet. Welcome back to our deep dive into the world of AI weather forecasting. We've been exploring AIFS-CRPS, and it's clear that this technology has the potential to really change how we understand and interact with our planet.
It's been amazing to see how quickly this field is advancing. AIFS-CRPS is already pushing the limits of what we thought was possible in weather forecasting.
Yeah.
And the research community is constantly working to make it even better.
We've talked about the implications for agriculture, disaster preparedness, and resource management, but I'm curious about climate modeling. Could this AI revolutionize our understanding of long-term climate trends?
Absolutely. Imagine being able to generate these highly accurate and reliable forecasts, not just for a few weeks out, but for decades into the future.
Decades, wow.
AIFS-CRPS could give climate scientists this powerful new tool. They could use it to simulate all sorts of potential climate scenarios and really assess their likelihoods with much greater precision.
So instead of just reacting to the impacts of climate change, we could get ahead of it, anticipate what's coming. That would be huge.
It would be a game changer for policymakers, urban planners, anyone trying to mitigate the risks of a changing climate. We could develop much more targeted and effective adaptation strategies, help communities prepare for the specific challenges they're going to face.
And we can't forget about water. I mean, weather plays a huge role in managing that resource. Could AIFS-CRPS revolutionize how we predict and manage water availability?
Imagine if we could predict droughts, months or even years in advance. Think what that would mean for agriculture ecosystems, communities that rely on water.
It would be transformative. We could optimize irrigation systems, manage water reserves much more effectively, and develop proactive strategies to deal with water scarcity. But with any powerful tool, there are always concerns, right? I mean, unintended consequences or potential downsides. What are your thoughts on that?
That's a really important point. Any technology, especially something as powerful as AI, needs to be developed and used responsibly.
Absolutely.
And the research community is very aware of this. They're working hard to make sure that AIFS-CRPS is used ethically for the benefit of everyone, not just a select few.
So what are some of the steps they're taking to make sure that happens?
Transparency is crucial. They're committed to making the inner workings of AIFS-CRPS as clear as possible so people can understand how it works.
Yeah.
And they're engaging with all sorts of experts, ethicists, social scientists, policymakers, to guide its development and use.
So it's not just about the tech itself, it's about the human element too, making sure it serves humanity.
Exactly. The goal is to create a future where AI empowers us to make better decisions, to manage our planet more effectively, not to make things worse or create new problems.
It's a good reminder that even with these amazing technological breakthroughs, it's still up to us to use them wisely. Well, this has been an incredible deep dive. I'm feeling a mix of awe and optimism about what the future holds.
I agree. It's a field that's constantly evolving.
Mm.
And with the power of AI, the possibilities are truly endless.
They really are. A huge thank you to our expert for sharing your knowledge with us.
It's been my pleasure.
And to our listeners, keep exploring, keep learning. The more we understand about our world, the better equipped we'll be to create a better future. This is the Deep Dive signing off. Until next time, keep looking up at those skies and never stop wondering.